Okay, this last video we're going to work these two practice problems. Okay, in this problem we're given the enthalpy of the reaction for the combustion of carbon into CO2. We're told that's exothermic, negative 393.5 kilojoules. And we're told for the combustion of carbon monoxide into carbon dioxide is minus 283 kilojoules. That's the information we're given. Then we're asked to calculate the enthalpy for the combustion of carbon into carbon monoxide. So let's figure out what we're going to do. The first thing we want to do is write our equations so that they add up to our net. This is our net equation. This is what we want to end up with. So I'm going to rewrite that down here. I have carbon solid plus 1/2 O2, 1/2 a mole of O2 as a gas, making carbon monoxide as a gas. And my delta H, my enthalpy for that is unknown. All right, I need to find steps that will add up to this. So I'm going to look up here at my first reaction. I have carbon plus oxygen makes CO2. I have carbon here as a reactant, and in my net reaction I have carbon as a reactant. So this might be helpful. So I'm going to write this up here. Carbon as a solid plus O2 as a gas makes CO2 as a gas. And the enthalpy for that is exothermic, minus 393.5 kilojoules. Then I have, okay, I'm going to look at my next thing. This takes care of the carbon. I'll put a little black check there. But I still don't, I have O2 here. And I have O2 here, but this is half and this is a whole. So that might work out. But on my product side, I need to have CO2. And, whoopsies. On my product side, I need to end up with carbon monoxide, because this is the reaction we want to end up with. And I don't have carbon monoxide on the product side here. So let's see what else we have to work with. I'm going to look at this equation. And here I do have carbon monoxide. Sorry that I wrote it as a... I don't think I'm going to be able to erase this off it. But it's a reactant. I want carbon monoxide as a product. So I'm going to reverse this reaction. I'm going to write it down here, but I'm going to write it in reverse. I'm going to write these two reactants as my products. I'm going to say I'm going to make carbon monoxide gas and 1/2 of a mole of O2 gas. And since I'm reversing this, my reactant will be carbon dioxide. Now, since I reversed this way, going this direction, it was exothermic, but in reverse it will be endothermic. So the enthalpy change will be the same amount, but the other sign, 283 kilojoules. Now let's see what we have here. Let's get a new color. We'll get blue. So we have carbon monoxide here on the product side, and we have the carbon on the reactant side, and that's what we need here. So let's add these up and see if when we add this reaction to this reaction, if we get the reaction in purple. So what do I need to do here to make this more legible? I'm going to make this a little smaller. Okay, now bear with me. I'm just going to circle this in purple. I can't separate it. I'm going to be adding the things that I'm circling in red right now, and I'm going to write them down here. So I'm going to bring down all my reactants from what I've circled in red. So I have carbon plus O2 as a gas plus CO2 as a gas. Those are my three reactants. And now I'm going to add all the products. So I'm making on this side CO2 as a gas. That comes from here. And now I'm going to have CO as a gas. And finally, plus 1/2 O2 as a gas. And that comes from here. All right, let's look. So now we have this equation. It doesn't look exactly like this one, but perhaps there's something on both sides of this that we can cancel out. So we have O2 on both sides of this. Here I have a whole O2, here I have half. So I'm going to take half away from both sides. I'm going to take half away from this side, and if I take half away from 102, I'm left with a half. what else do we have on both sides? Well, we have CO2 on both sides, so I'm going to cancel that out. Now, let's look. This reaction right here, I have carbon, plus a half O2, plus a half O2, makes carbon monoxide. So this reaction now is this one in purple. We added these two, and we came up with this once we canceled out things on both sides. So to find the enthalpy for this, since I added these two reactions to get this reaction, I'm going to add these two enthalpies to get this enthalpy. Hess's law allows me to do that. If I add negative 393.5 kilojoules and 283, I don't have a calculator handy. Let me see. Okay, I did this without a calculator. My math might be off, but I think that when you add this up, it's negative 110.5 kilojoules. If you add negative 393 and 283, I hope. So that's how you add the equations. Let's see if we have time to do another. So that's going to be the end of the videos for this lesson. I'll go over the next practice problem in class.